Alright, so the easiest way to perform vector addition is to view it like a path, with you have a starting point and you have a destination, but your path might be not a perfectly straight line, and it probably won't be, but your resulting vector is just going to be a direct line from your initial point to your final point. So I know that can be a bit confusing, so I have an example here. Let's say we want to do v1 plus v2 plus v3. Now let's say this here is our starting point, and now we just add in order. We do v1 first, then v2, then v3. So from our starting point here, we're going to draw v1, and then from that point we're going to draw v2, and then from that point we're going to draw v3. Okay, so that's our path, and it's not a straight line, it's nowhere close to a straight line, but our resulting vector is a straight line from where we started off at the very beginning to our destination at the end, and that's what our resulting vector is. And I think the coolest part about this is it doesn't matter which order you add in. So let me get a different color here. And now instead of starting with v1, let's do v3 plus v1 plus v2. Alright, I'm going to use the same starting point. And remember, this one is what we should end up with. So let's add in this order. Let's start with v3. Alright, v3 right here. And now we do v1, starting from where v3 ended off. Should look something like that. And then we add v2, which brings us back up here. Alright, so we can see that we ended off at the same exact point as where we did the first time we did this. And you can mess around with that if you want. You can do any sort of combination of vectors and see that you will get to the same point. Now, that's only if you include all three vectors. If you only do v1 and v2, you're not going to get to the same point. Now, physics professors, physics teachers will call this the tip to tail method, where the tip is where the arrow of the vector is. So this right here, that's the tip, and then the tail is down here. So if you want to add, let's say v1 and v2, you can draw v1, and then you put the tip of v1 to the tail of v2, so you're going to draw v2 up from there, and then the resulting vector again is from where you started initially to where you ended up. So that's your final vector. Alright, now let's try another example, but this time we're going to do some subtraction. So let's say we'll start with v2. Why not? We'll do v2 minus v1 plus v3. Alright, so how are we going to do this? So whenever you see a subtraction symbol in terms of vectors, that just means that you're adding the opposite of the vector. So it's just going to have the same magnitude, but it's just going to be flipped in the opposite direction. So all this means, we can just choose a starting point. We'll start with v2. v2 looks like that. We're starting with v2 because it's the first one in our equation. Then we have minus v1, so we're going to take the opposite of v1. It's going to be the same length, but it's going to be pointing down instead of up. Alright, and then we add v3 to that and come down here. Alright, and then remember, our resultant vector is from where we started to where we ended up. So that is our resultant vector. Now there's one last important thing to consider when doing vector addition, and it involves multiplication actually. So let's see if we can come up with another problem here. We're going to say this is going to be the ultimate vector addition problem. Alright, so we're going to say 3 times v3 minus v1 plus 1/2 of v2. Now I know this can look intimidating if you ain't never done anything like this before, but it's very important if you're doing physics or linear algebra to know what all this means. Alright, so 3v3, that just means you're going to multiply the length of v3 times 3. So v3 is kind of short right there. We just need to make it 3 times that length, points in the exact same direction. So that's all we need to worry about. So we're going to say that's about 3 times the length of v3. I'm just eyeballing it here though. Now we have negative v1, so remember, we're just going to flip v1 in the opposite direction, but it's not being multiplied by anything. So the length of v1 is not going to change at all, it's just the direction. So it points down, about the same length. And now we have 1/2 of v2 that we're adding to it. So that just means we're cutting the length of v2 in half, and it points in the same direction. I reckon that's about half of v2, and our resultant vector is, of course, from where we started off to where we ended. Alright, so I hope all that made sense. Ask questions in the comments if you want to, and good luck on your test tomorrow. I know you'll do great.